Hi, welcome back to this video series on cryptography. Today I'm going to talk about some basic foundations of probability that we need. For example, when we talk about perfect secrecy, we need basic notions like conditional probability, Bayes theorem. So I would like to explain some of those basics so we can follow the rest of the cryptography series. Okay, let me take a simple example. Suppose you're having a simple coin, unbiased coin. An unbiased coin can have two outcomes, head or tail, right? And so the event that are possible in this case could be head or tail. Okay, these are the only two possible outcomes when you toss a coin. Okay, there is something called random variable. What it means is that we associate a mapping between each outcome, a number between 0 and 1. Okay, for example, let's say my coin favors head often than tail for some reason, then I would say for example 0.55 and 0.45 for the tail. Okay, so you can imagine a random variable is just a mapping between your space of outcomes to a particular number between 0 and 1. Okay, head is mapped to point. Okay, you could say like what is the probability head happens is 0.5. Usually in a fair coin you should get 0.5, but I'm just showing you it's not necessarily always the case. 0.45. Okay, so if you add your probabilities, you should get 1.0. Okay, that's basically the idea of probability, right? At a very high level, very informally. Okay, so let's take this step to the next level. Okay, suppose I have two events. Okay, maybe I'm tossing a coin as well as rolling a die. Okay, I would like to know what is the probability that I get a head and I get number 4. That is called joined probability, meaning you have two events. Okay, so joined probability in that case means you have multiple events, in this case 2 events, and you're trying to compute probability of 2 events, okay, happening at the same time. Okay, that's called the joint probability. So let me write a little bit of a notation here. Suppose you say you have a variable x, random variable x, which is basically it could be the fact that you want a head on the first on your coin toss. Another variable y, which could be that you want to have an even number on your rolling a die. Okay, so it is like something like this, right? What is the x denote? X is the I want like to have head here, I would like to have a head here, and I would like to have an even number on my die. Okay, it's a dice that I'm rolling and I would like to have an even number. Okay, so if you have two variables like x and y, then we call it joined probability. Okay, we are trying to find at the same time. Okay, we want this to happen. So our intuition must be telling us that we can write this as probability of x given y. Okay, let me explain what that is in a moment. That means you have observed that y has already taken place. Okay, and now you're looking for x given that y happened. Okay, and there is also a probability for y to happen also, right? So what is the meaning of this statement, x slash y? Okay, let me explain this. Suppose you're doing an experiment, y has happened. Okay, given that y has happened. Okay, maybe assume this scenario with y being even. Okay, suppose you're rolling a die and you got say 6 to be your number output. Okay, that's an even number. So you got an even output, but you are asking what is the probability that both numbers are same when you are rolling your die. For example, 1 1 2 2 3 3 4 4 5 5 6 6. Let's say let's take a different example. Let's roll 2 dice, okay? Die 1 and die 2, okay? So that will be more clearer now. Let's take 2 dice, die 1 and die 2. You are going to define a variable. Let's say that the variable is called double, okay? Double is the variable. It denotes if both dice have the same output, okay? For example, it could be 1 1 2 2, right? That means you're observing 1 on the first die, 1 on the second die, or it could be 2 2 all the way up to 6 6. There are 6 possible pairs like this, right? That's the double, okay? Suppose I define another variable, right? This is one variable, D. I define another variable, E, meaning even, okay? When you add the outcome, the numbers have to be even numbers. For example, on the first die you got 1, on the second die you got 1, or 1 3 1 5, okay? Not 1 6, because 1 6 is 7, right? So set of all x y, right, or AB, let's call it AB for a moment. A is the outcome that you are seeing on the first die, B is the outcome on the second die, and if you add A and B, right, when you A and B must be an even number. It's an even number. I'm writing it really informally, that's fine. It's an even number, okay? So now we can define conditional probability more precisely. When we write probability like this, for example, probability that for example, you saw a number 4, okay, as part of the total, and you would like to know what is the probability that the outcome has same value, for example 2 2, okay? So let me rephrase this more clearly, okay? You saw outcome of rolling 2 dice, okay, and you added the numbers, okay? So you got 4. You could have got 4 for many reasons, right? You could have got 4 for 1, for example. When do you get 4? 4 you could have got for combinations like 1 3 2 2, right, or 3 1, okay, or 3 1. So multiple reasons, or 3 1. These are the 3 possible pairs, right, that could have given you a 4, okay? So what is the probability that you get a double given that 4 has happened is 4 has happened. We are asking what is the probability it is double, right? So we can look at it. There are only three possibilities where you can get 4 out of all the possibilities. Only 3 possibilities, okay? Either 1 3 2 2 or 3 1. And double means you're only looking for the same value, 2 2. So that means it's only 1/3, right? So only 1/3 probability that you get a 4 and both numbers are the same. Okay, this is the meaning of conditional probability, okay? And we can now compute the other side as well, right? Let's say, or other direction. Suppose you saw a double. Double could be what? 1 1 2 2 3 3 and so on. So, and we are asking what is the probability that when you add those two values, you get 4. So we can quickly see this. Double has only 6 possibilities, okay? And when will you get 4? Only one possibility. 2 2 will give us 4. So answer is 4 by D is 6. So what we learned here is that D by 4 is not the same as 4 by D. Okay, that's the first thing. The second thing is that we can now go back to the previous formula that I talked about. If you have 2 variables, we can connect them like this. So, for example, there are 2 variables, x and y, okay? The joint probability of 2 variables, x and y are 2 variables, and you would like to know the joint probability, is same as x given y has happened, and means multiplied by probability that y happens. Okay, this makes sense if you think about it intuitively. We are looking for the probability that the two events x and y happen, two events happening at the same time. Okay, that means we can assume y happened, and then we are looking for what is the probability x happens, and multiply with the probability that y happens. Okay, that's first equation. We can actually swap x and y, right? Just like x and y are two variables, and we can swap them. What will we get? We are asking the same thing, right? These two are not different. You are saying x happens and y happens. Similarly, y happens and x happens. Is equal to, we can say, let's look at what is a, given that x happens, what is the probability y happens, and probability of x happening. Okay. If you notice carefully, this is intuitively clear. The left-hand sides are both equal to each other, right? These two things are equal. We are just looking for two events happening at the same time. It could be you want 4 and double is same as saying double and 4. There's no difference. Okay, like in this previous example. So that means these two things are equal. Therefore, we can combine 1 and 2 easily as follows. We could just say probability of x. Since the left-hand sides are equal, we can now combine the right-hand side as follows. Is same as probability of y is equal to probability of y over x given, okay, let me be consistent a little bit. I will try to, so this is capital Y because I'm referring to a random variable, right? Okay, is, and then it's a capital X, and equal to probability of x. Okay, so now let's assume probability of y is non-zero for a moment. Then we can rewrite this as, because this is equal to these two expressions equal, therefore we divide both sides by probability of y. So we get a nice structure like this, is equal to probability of y given x into probability of x. Okay, and now we are dividing both sides by probability of y, right? Therefore, this is basically a nice little formula that helps us to compute one conditional probability knowing the other direction. Okay, that's really nice, and this is called the Bayes theorem. X, probability of x given y is same as probability of y given x times probability of x divided by probability of y. The way I remember is this y should always come here, and this x should come here. Okay. All right. So what did we learn? We learned this very nice trick that given y to find x, we can use given x find y. If we can do that easily, we can compute the other direction easily. That's basically the the main thing I would like to tell you. Now let's apply this idea and play with it. We take an example, right? The double space. Double means 1 1 2 2 3 3 and so on. We are rolling two dice, right? And we are measuring a simple probability. Okay, let's say we are measuring the probability that what is the probability that we see 4 and we get double? Okay, so this is the probability we would like to measure. I'm going to use the Bayes theorem and show to you that we can do it in using Bayes theorem. Okay, 2 2 and so on, and 6 6. So we have 6 items in our double space, right? Okay, so because we are rolling 2 dice. Now what is the probability that we saw 4 and we would like to know it is double? Okay, meaning 4 means we got the sum to be 4 to be more precise, and we would like to know whether it's double or not. Okay, intuition tells us that how many ways can we get 4? We can get 4 by 1 3 2 2 3 1. There are only 3 ways we can get 4. So the denominator will be 3, and we are asking it is also double. So that means we have to pick only one, right? Number 2, because that's the only number that is double. Okay, so it is d by 4 is 1 by 3. Let's do Bayes' theorem to compute 4 by d. Okay, what is 4 by d? For given d is d given 4, okay, which we have already computed, and probability of 4, okay, divided by probability of d. Okay, so we can quickly do all of this very easily. What is probability of getting a sum to be 4? When we are rolling 2 dice, what is the probability the sum is 4? Either it can be 1 3, 2 2, 3 1. The 3 out of 36 possibilities, right? When we roll 2 dice, we get basically a square matrix, right? If I can quickly show you what I mean by this. 1 2 3 4 5 6 here on the first die, 1 2 all the way to 6 on the second die, right? So you're filling basically this matrix. That means there are 36 possibilities. That's the reason why probability of getting a 4 is 3 over 36. Okay, hopefully that is clear. So we know this. What is the probability of getting a double? Okay, that is easy to compute also. There are only 6 doubles possible, right? 1 1 2 2 6 6 out of the 36 pairs. Okay, which we can simplify further, right? This is 1 over 12. This is 1 over 6. Now we can plug in this, all of the things we have. What is the first part? 1 3. Second part is 1 12. And the denominator part is 1 by 6. Okay, so we get 1 by 36 divided by, so we found out the probability of 4, meaning we get a total of 4 when we roll 2 dice. Given that we get a double is 1 over 6. Okay, we can now also apply intuition to check that, okay, without directly calling the Bayes theorem. Let's do that. Without doing this right hand side, we know that we got a d, right? Okay, what are the possible ways we can get d? There are only 6 possibilities. So 1 1 2 2 and so on, 6. Okay, and we would like to know what is the chance that we get a 4 in the total. That means there is only one possibility, 2 2, right? Because we have to limit ourselves to this set of d, because we are saying given d happened. So it's 1 by 6, and you see here exactly the same thing when we apply Bayes' theorem as well. So these two are equal, of course. Okay, so what we learned today is that Bayes' theorem is a very nice construction that helps us to compute probability of x by y using probability of y by x. Okay, that's basically the main message of this tutorial, of this segment. In the next segment, we will apply Bayes' theorem concept for perfect secrecy, and show to you how that helps us to test whether a given encryption scheme satisfies perfect secrecy definition or not. Okay, that's all. Thank you very much.